Hello learners, welcome back to the education program online with me teacher Christine, taking you in mathematics for senior 3 and senior 4. So dear learners, our topic remains algebra, but under algebra I remember I explained to you that we have a quadratic expression under algebra, and then we also have what we call the binomial expression under algebra. So the word binomial, bi means two. So the concepts that make up or that form up what we call the binomial expression, in the previous lesson we looked at one, which is permutation, and we said when we are dealing with permutation, especially for those who are taking additional in senior form or senior 3, they will always ask you define permutation. So we say permutation is any arrangement of element taken from a set or a group of set, and the order is taken into consideration. And we said that arrangement simply involves the two orders. It may be a descending order or ascending order. But when we look at permutation, we always take it descending order. And we went further looking at some of the examples. How do we calculate permutation? Where we said we can calculate permutation using a formula which is stated as P equals to P raised to n base R equals to n factorial over n minus R factorial. Dear learners, we said this formula we simply use it in permutation simply because n factorial simply means the short form of writing defining or stating permutation. And then n minus r means that you are to reduce the number or subtract the number of operation or the number of elements minus the times you can take to arrange your elements. So n simply means the number of objects or the number of elements that you are going to arrange. And then r simply means the number of times. How many times are you going to arrange your element? Is it once? Is it twice? Is it 3 times? So it depends. So that is the formula that we looked at in the previous lesson. And then now I remember we stopped on problem solving in permutation. So for this case today, we are going problem solving in permutation. We said it's where you use your formula, you derive your formula, and then you apply it depending on how the question is. And then now today we want to look at how do we solve for the unknown in permutation. How do we solve for unknown in permutation? Solving unknown. Solving unknown in permutation. Solving unknown in permutation. So dear learners, this is what we are going to look at. How do we solve unknown in permutation? In most cases, they will always ask you simplify or solve, and then they give you the equation. So you have to use the knowledge of permutation in solving it. For example, they may say find the value of unknown. Our example one. We say find the value of unknown. Find the value of unknown. The value of unknown for the following. the following. For the following, and then they say A, we have P raised to N, P raised to N base 2 equals to 120. P raised to N base 2 equals to 120. And then part B, our part B is P raised to N base 2 equals to 30. So dear learners, in this case, when you are given to questions of this nature, then you are expected to apply what we call a permutation, that is under solving or finding for unknown. And therefore, for you to find for the unknown for this case, then you need to state the formula of permutation. So when we state the formula of permutation, it is our formula will be P raised to N base R. And we know that R is the number of times and N is the number of elements. Then now, which is equals to N factorial over N minus R factorial. Minus R factorial. Dear learners, you remember that when we said N factorial, it means that you descend that number up to the lowest term. And our lowest term in this case is 1. So if we are to descend the number N, which is the number, you are to descend it to up to its lowest term. So when we substitute this, we find that it is the same as what? It is the same as P raised to N base 2, which is equals to N factorial over what? Over N minus 2 factorial. So over N minus what? Minus 2 factorial. Then now, what does N mean? You are to descend it. Then, which is the same as, I will descend what? I will descend N factorial until I will reach to this level of N minus 2 factorial. Remember when I showed you the shortest way of how to factorize or how to simplify the factorials instead of moving from the given number up to 1. So we simply say I will have our N, open the bracket, N minus 1, close the bracket, open the bracket, N minus 2, close the bracket. So since N minus 2 is the same as the denominator, then we can eliminate now our denominator by dividing it, and then you say N minus 2 factorial. N minus 2 factorial, which you can cancel this and you cancel with that. And then now you remain with the numerator, which is N into N minus 1 factorial. So this will now be equals to our what? Our value here, which is 120. 120. Then now from that, you will only be remaining now with the N into what? Into N minus 1 equals to 120. Then now you will open your bracket. It is another way of trying to create or to form what we call a quadratic equation, because we are still dealing with the algebra. And then now when we open the bracket, we get N factorial N square and then n times negative 1, we get negative n, and then we can now form our what? Our equation, which we said our equation ends with what? Ends with 0. So now we shall have n square minus n equals to n square minus n. 120 will cross the equal signs and becomes what? It becomes negative 120. So the whole equation will be n square minus n minus 120 equals to 0. So at this level, learners, this is where you are going to do what? You are going to factorize, because it is already giving us what we call a quadratic equation. So when we factorize this, we simply break the first term and the third term. So when we are breaking it, you get x times x, sorry, n times n will give you n square. N times n will give you n square. And then now we also look at the what? We also look at the factors, the numbers that we can break or multiply to give us 120, and then when we add them, it must give us what? Negative 1, which is negative n. So you find that we have negative 9 and then positive 8, because when I multiply this, I will automatically give me 120, and when I add them, I will get negative 1, which is n. Then now you will correspond them, that in n will go with the negative 7 and negative 9, and then n will go with the positive 8. So we shall have n plus 8 and then n minus 9. N minus 9. So, dear learners, at this point, now you solve for n. So, when we solve for n, definitely we say 9n minus n plus 8 equals to 0, of which n alone will give us what? Will give us negative 8, or n will give us positive 9. So, dear learners, this is how you simply find the value of unknown. So our unknown is given as negative 8 and positive 9. So when I substitute it there, it will give me what we call 120. So dear learners, that is the solution for part what? Part A. Then now we also move to part B. So our part B, for this case, you say part B, we also do the same. You state your formula, and then after stating your formula, you substitute. So we shall have P raised to n, and then 2, which will give us n factorial over what? Over n minus r, sorry, minus 2 factorial. Minus 2 factorial. So this one simply means you also do the same what we have done with part A. Move n until you get what? Negative 2, negative n minus 2 factorial. And then you eliminate the fraction, because we cannot find a solution where there is a fraction of this kind. You will not be able to arrange your element in the order. So we simply say I will have n into n minus 1 into n minus 2. Since this is 2, we say factorial over what? Over n minus 2 factorial. So that we can now eliminate the division, and then we say equals to what? Equals to 30. Equals to 30. So when we eliminate the division, we remain with the n into n minus 1 equals to 30. Then now you open the bracket, which will give us n square and then minus n, and then this is 30 automatically will give us what? A negative 30. So this will be your equation. It is reflecting a quadratic equation which is not in a well-ordered manner. So we shall have now n square minus n minus 30 equals to 0. So then now you factorize this. You factorize now that to give us the factors of, or the value of n. So when we factorize that, we simply get n square minus n minus 30 equals to 0. So when we break this, we get n times n. And then when we break this, we get negative 6 and what? And 5. So this will automatically correspond to one another. And then we shall have n plus 5 and n minus 6. N minus 6 equals to 0. Then now you solve for n. You solve for n. If we quit n plus 5 equals to 0, automatically this will give us a negative. So our answer now will be n equals to negative 5, or n equals to positive 6. So learners, this is our answer for this example part B. Then now I want us to look at example 2. Example 2. So example 2, they will tend to ask you simplify. Simplify when they have not given you the value to what it equates to. So they will say simplify example 2. Our example 2. So example 2, they will say simplify a n factorial over n minus 3. N factorial over n minus 3 factorial. And then B, they may say n factorial over n minus 2 factorial. So dear learners, you can be given just a check on this, how to simplify it. So if you are asked to simplify when they have not given us the possible value to what this given unknown is equals to, then you only do what? You only simplify and you leave your answer in unknown. So you will come to your solution. You say, my solution for this case now, we all know that our permutation is given as a p raised to n base r, which is the same as n factorial over what? Over n minus r factorial. So at this moment, we don't know the value of n, but we know the value of r. And what is the value of r here? The value of r is 3. So you will have p raised to n, and then base 3 equals to n factorial over n minus 3 factorial. So don't always rush by saying that since there is nothing here, I am no longer going to state the formula. Take note of this, that in mathematics, the formula matters a lot than your working. The formula matters a lot than your answer. Because you cannot arrive to the possible answer unless you have known what key are you going to use. So let us try to simplify this. So this means that you are going to move n until we get where? You will get it into n minus what? Minus 3 factorial. So we shall have n factorial over n minus 3 factorial. 3 factorial, which will give us now n into n minus 1 plus the bracket into n minus 2 plus the bracket into n minus 3 factorial plus the bracket factorial. So, dear learners, you will have to move n until you get the denominator. And then our denominator is n minus 3 factorial. So n minus 3 factorial is the same as that n minus 3 of the numerator. Then now you will cancel this. And then now you will have your answer as n into n minus 1 into n minus 2. Dear learners, you'll stop there as your answer. If they ask you, just simplify. Simplify, that is what the examiner requires from you. And then when we come to part B, and part B, dear learners, from this example, you can work out to part B. So, in other whatevers, other books, learners, you can still even factorize, multiply this. You can multiply the first bracket, outcome of it, multiply with the second, the third bracket, and then you quit it to 0. That is when you are to inform what we call equation. But if they ask you just simplify, you'll stop to that level. And then we move to part B. So our part B also, you say, I will have part B, you will say I will have n factorial over what? Over n minus 2 factorial. So you state our formula as p raised to n base r, which is given as n factorial over n minus r factorial. So dear learners, the examiner is so much interested in seeing your way, the working than your answer. So after stating your formula, definitely someone will know that this boy or this girl knows what she or he is doing. And then now you will have p raised to n base 2 equals to n factorial over n minus 2 factorial. N minus 2 factorial. And then it means you are going to move this up to where we get 2 factorial, which will be n into n minus 1 and into n minus 2 factorial. So this, then you'll eliminate your fraction all over n minus 2 factorial. So this will cancel, and then you remain with your possible answer as n into x, n minus 1. So you remain with the n into n minus 1. Which will now be n into n minus 1 factorial. This is the same as if we are to simplify up to the n, then you will get n square minus n equals to 0. So you will simplify up to that level. But in most cases, we stop in that level 1 of after you are eliminating the fraction. So dear learners, with solving unknown in permutation, I just wanted you to get that clue so that it doesn't take you by surprise. And I want you to have these questions as your exercise. You try them in your free time. So they say solve the following. Solve the following. Solve the following. We have A, P raised to N base 2 equals to 16. B, we have P raised to N base 3 equals to 120. And then we have C, P raised to N base 2 equals to 72. And then part 1, part 2, we have simplify. A n factorial over n minus 3 factorial. And then B, we have n factorial over n minus r factorial. So, dear learners, you try to have that one as your exercise. And I hope that, my dear learners, you have picked something on this of under permutation. So now, my dear learners, we are moving to the second part of binomial expression. Remember, we said when we are looking at binomial, bi means 2, and we said it is consisting or containing the components of binomial. They are always 2, and that is permutation. And then the second one, which is we treat it as B, that is combination. So, dear learners, we shall pick up from that part of combination in our next lesson. And I want to wrap up this lesson that we have just had, that permutation has 3 or 2 major questions that they will always ask you. They will ask you to define permutation. They will ask you to solve problems in permutation, and then simplifying permutation. With this, dear learners, I hope that if you have been following me from the beginning of permutation up to where we have stopped, I hope that you might have picked at least something from this lesson. And if you continue revising it, you will be able to attempt any question in permutation. Remember, it is arrangement that considers the order. Elements are arranged from in a descending order. With this, dear learners, we have come to the end of our lesson, and we shall pick up from part B, that is combination, in the next lesson. I wish you well. Goodbye.